Today I want to show you an early idea of how Zircon3D can be used for greenhouse monitoring. What you're seeing in this video is actually the current Zircon3D Home version, running on Home Assistant without any special greenhouse edition yet. But even with this setup, we can already build something very close to a real greenhouse heat map. We are also actively developing a dedicated Zircon3D Greenhouse version. It will include more realistic, greenhouse-specific models, such as greenhouse structures and layouts that better reflect real growing environments. And we'll share an early version for demo in the coming months when it's ready. In this demo, I'm using Home Assistant template sensors to represent greenhouse data, things like temperature or humidity across different areas. They're just simulated values, but the structure is exactly the same as real sensors you would deploy in a greenhouse. Here I've modeled two simple greenhouses using the same home design tools, and it already works naturally for greenhouse layouts. The heat maps are driven directly by Home Assistant sensors, showing how values change spatially across the greenhouse. You can immediately spot hot and cold areas. Yellow here indicates around 23 degrees Celsius, while the blue area over here is closer to 14 degrees Celsius. Now, if we switch to the humidity heat map, blue indicates higher humidity, while yellow to red represents lower humidity, which can directly impact crops or plants in those areas. Temperature and humidity are both critical factors in a greenhouse. When temperature and humidity are combined, they directly describe plant transpiration conditions. In this VPD heatmap, it visualizes how plant transpiration pressure varies spatially across the greenhouse. Blue areas indicate low VPD, where the transpiration is limited, while yellow to red areas indicate high VPD, where the air is too dry and plants may experience stress. Because VPD is calculated from both temperature and humidity, this view helps reveal microclimates that are often hidden when looking at charts or averages alone. This heat map is a diagnostic view that helps reveal how climate conditions vary across the space. Next, this is the light intensity heat map. It shows how light is distributed across the greenhouse, making it easy to spot underlit or overlit areas. The color thresholds for all the heat maps are fully configurable, so users can adjust the value ranges and colors from the configuration page to match their crops or lighting strategy. The last heat map I want to show is soil moisture, where yellow to red highlights dry zones and blue indicates very wet areas. Soil moisture is especially important in greenhouses because uneven irrigation or drainage can directly affect root health and plant growth. As we continue developing the Zircon3D Greenhouse version, these heat maps will become first-class features with greenhouse-specific structures, zones, and models designed specifically for this kind of environment. Different users care about different layers, growers, operators, and lighting designers, and Zircon3D supports all of them within the same visual model. Thanks for watching, and I'll share more updates soon.